Okay.
Without a diffraction pattern, there's no wave to describe. Do you understand that?
Okay.
So there's no light wave to describe when you take a picture.
I don't know who's claiming wave.
You are. You say light traverses a medium and it needs to traverse a medium because it's a wave. So here's Simon Dan's image of no drift, because me and my reference frames are ruined according to him when he annihilates the globe claim. This was taken with light. So I want you to pick any part of this image whatsoever and tell me where there's light capable of being described with a diffraction pattern or a frequency. Light diffraction, useful for coming up with a convention to describe all the different types of light with wave function, later described as wavelength for each of the different types of light. Only achievable if you cause that particular type of light to diffract to get a wave function. If it's not diffracting, there's no wave function observable, therefore no wave. So the ether's screwed. Where's your wave? There isn't one.
Calibrated differently, but to say that it's picking up light, well, it's only picking up a certain range or frequency of light. It's not that there isn't light, it's just
Sure.
calibrated to specifically find a certain one.
Sure, but when it's described as picking up light that's been traversing an ether, that's a wavelength travelling to the camera as a wave.
That's the mathematical description of what's happening.
No, it isn't. That's what I'm trying to explain to you. Light doesn't reach the camera as a diffraction pattern. That is not how it occurs at all.
Yeah, but energy reverberates, and energy reverberates.
Sorry, where's
based on the material it interacts
Sorry,
with.
reverberates like a frequency. No, that's incorrect. I'll say it again. That description of wave function is of light diffraction. Cameras aren't taking pictures of light diffraction. Now, you might take a picture of a diffraction pattern, but the picture itself isn't diffraction. It's just a picture. And the way the light's reached the camera isn't as a wave. Now, if you say, well, the particular spectrum of light is described in infrared as this wavelength, yeah? If it's diffracted, and you've quantified it mathematically as the diffraction pattern, as a probability distribution, aka wave function. But that's not what reaches the camera. Just light reaches the camera, not diffracted light. Not light. Light isn't always traversing a double slit and diffracting, so you can come up with wave function for it.
Right.
So light's not reaching the camera as a wave in any way, shape, or form.
Yeah, but even then in the double slit, there's still the slit. That slit is affecting the light that goes through it, and that changes what you'd call, I guess, the wave function of the light that initially was there before it went through the slit.
That's incorrect.
So how you describe that? I mean, you can describe that any way you want.
Just
in any
diffraction.
sort of mathematical
Diffraction.
interpretation,
That's how I
but it's
describe
still
it.
just
Diffraction.
One
word.
frequency
Diffraction.
of it.
That's what I describe it as. Diffraction is the same as interference. That's what it is. So what you're describing when you get wavelength is interference. Cameras don't take pictures of interference. They take pictures of light. They don't take pictures of diffracting interference from light, where you don't know whether or not it's going to hit this part of the sensor or that part of the sensor. Light comes into the sensor and hits it. That's how light behaves. More akin to wave function collapse. Not wave function, not probability distribution. That's not typically how light behaves. While light can diffract, it's a natural phenomena that you can study. It's not the typical behavior. And the typical behavior doesn't have any description to give you a wave for the ether.
Illumination, being visible light, which is the attribute of light itself, actually has a frequency and therefore has waves.
What's the frequency?
Well, that's all dependent on
It's wavelength?
some
It's wavelength.
specifics.
It's diffraction pattern. That's where you get wavelength, it's frequency. From the diffraction pattern.
Right,
I just explained
frequency.
this 30 seconds ago.
Yeah. Okay.
I just explained it 30 seconds ago, Dicely. So, given that to derive wave function, you need a diffraction pattern. You understand that?
Okay.
Without a diffraction pattern, there's no wave to describe. Do you understand that?
Okay.
So there's no light wave to describe when you take a picture.
Was that a question or a statement?
It's a fact. The derivation of the word wavelength for a particular type of light is a description of its interference pattern. Now, we don't see light that way. You might walk under the sun and have some light going through a tiny little slit between two leaves of a tree and diffract before your very eyes, and you see the interference pattern. That's reasonably easy to stumble across in nature, light diffraction. But your camera isn't behaving that way. It's not taking light in and presenting a diffraction pattern on the sensor. Not at all. So given that there's no light diffraction at all in this picture on screen now, we're seeing light in the sensor, not diffraction that can be later described as a wave function in the sensor. That's not happening. So I'm asking, given that statement of fact, that there is no diffraction here. This is not an interference image. It's an image. It's actualized. And if it's actualized, where's the wave for the light to travel through if it needs one?
Well, do you think that that diffraction is caused by the eye itself? Like, the eye itself is similar to a camera in the sense that it has a certain, I don't know, you'd want to call it frequency.
You're
or
under the impression, Zinclenser,
light.
that cameras are taking pictures of diffraction patterns, generally speaking, are you?
Yeah,
They're
we
not.
make a camera.
Cameras aren't taking pictures of diffraction patterns.
Simulate.
Just say it one more time. You prefaced your question based on the idea that the camera works like our eye when it sees diffraction patterns. And I've said 4 times, that is not what a camera's taking a picture of. Cameras don't take pictures of diffraction patterns. They can, if you induce one and cause light to diffract. But generally speaking, diffraction, aka interference, isn't what you want to achieve when you take a picture of something. You're not trying to achieve an interference pattern. You want the light to be actualized, actually hit on the sensor where it's supposed to hit, to give you a nice sharp image. But given that you get a nice sharp image and there's no diffraction pattern in this photo on screen, or basically any photo in any of the reels that I've got that I can present, unless it's specifically of a diffraction pattern, there is no diffraction pattern, therefore no wave function to describe with light when it is appearing as it appears. So I'm asking, if there's no description in a standard photograph of light diffraction, how are you going to give me a wave for the light to move through?
You're not.
Say again, Chocolate?
You're not.
No, you can't.
I was just going to say, I like how you just made the distinguishment between the phenomenon and what is, right? Because it would be like saying, I see water boiling, therefore water is bubbles.
Yeah. Light diffraction, useful for coming up with a convention to describe all the different types of light with wave function, later described as wavelength for each of the different types of light. Only achievable if you cause that particular type of light to diffract, to get a wave function. If it's not diffracting, there's no wave function observable, therefore no wave. So the ether's screwed. Where's your wave? There isn't one.
Well, Aether never claimed waves are a thing.
Is that a bit like nobody claims the horizon is Earth curve?
I'm just saying waves aren't a thing of themselves. They're what things do. So,
okay. Okay, it's what something does. So
like,
how is light doing waves? How is light doing waves?
It's just constructive and destructive phase due to the spatial
No, that's
variance.
an interference pattern. That's a diffraction pattern. That's when light has a diffraction. That's how you can describe wave function. Light's not diffracting in this image on screen. On screen now, there's no diffraction patterns to describe with wave function, as you were about to launch into. Where's the wave function in this picture? There's lots of light in this picture. This was taken with light. Now show me the diffraction pattern to describe a wave function within this image. Go.
Diffraction patterns are more pronounced when you have coherent light sources as opposed to incoherent light sources.
That's fascinating. And where's the diffraction pattern in this picture?
Camera,
where's the diffraction pattern in this picture?
Have a pronounced
where's the diffraction pattern in this picture?
I don't know what you're showing.
Any
that
picture.
That didn't sound like dust.
Any picture. Unless it's specifically of light diffraction. I've got a picture of the ocean. It's a sunset. Where's the diffraction pattern, please? For me to describe light as a wave function. Is there one?
Do you have a defined diffraction pattern with incoherent
interference?
Source,
It's interference. It's a diffraction pattern, aka interference. I have defined it.
You can have interference, Nathan, but
yeah, and if we haven't, i.e. in a normal picture, where's the diffraction pattern in a normal picture to describe light as a wave, aka wave function? I keep asking you where it is in a normal picture. Don't tell me you can.
As you were just showing. You're talking about coherent versus incoherent light sources. You're equivocating the effect from a coherent light source and then asking why you don't get the same effect with incoherent light sources. And that's what Napalm was addressing to you.
You can look at leads and see like the light from a diffracting. What are you talking about?
It's like the difference between
I just addressed how that's not incoherent. Did you just ignore what he just said about how that's not incoherent?
You have incoherent. You
just covered that. He said you can walk under a tree and see light diffraction. Is that incoherent?
It'd be out of phase, yeah.
Yeah, you can get similar effects in incoherent light.
Sorry, what do you mean out of phase?
Chromatic aberrations around the,
Hold on, stop.
outside.
Stop. Someone said out of phase. What do you mean out of phase? What does that mean?
It means it creates an inharmonic resonance between the two.
Oh, so it's a wave? No. Light described as a wave is a description of the diffraction pattern of light.
Well, I wouldn't go that far. I mean,
versus non-monochromatic.
All right, in a photograph, there's plenty of light. Would you both agree?
Of course.
So, therefore, we're going to be able to describe the picture with the diffraction patterns in the picture. Oh, no, there isn't any.
There's no coherency. There's no light coherency.
No coherency in a picture. It's just a picture. It's got light.
In a picture.
This is a universally applicable nonsense to light. So I want to know if universally light's going to travel as a wave in a non-diffracted image. That's basically all of them. Where's the diffraction pattern to describe light as a wave? When you say it's out of phase, yeah, that would be a wave. Where's that wave? You need a diffraction pattern to describe it being out of phase. There isn't one in this image, or any of the images that have been on screen since we started this discussion. No diffraction patterns on any of the pictures.
That wave.
Are you saying wave and frequency are identical terms?
Right, wave versus frequency. Frequency of the wave. Frequency of the wave length. Yeah, that would be derived from a diffraction pattern. Light isn't generally diffracting. This image on screen has no diffraction in it. So therefore, where's the light wave going to come from? Where are you going to describe any of the light in any image with diffraction in it when there isn't any?
And would you agree that there is a difference in the way we describe a wave and a frequency, but there are similarities?
Like, where's the wave in this image? I've got an image on screen and it's got light in it. Where's the wave?
I don't know who's claiming wave.
You are. You say light traverses a medium and it needs to traverse a medium because it's a wave. So here's Simon Dan's image of no drift, because me and my reference frames are ruined according to him when he annihilates the globe claim. This was taken with light. So I want you to pick any part of this image whatsoever and tell me where there's light capable of being described with a diffraction pattern or a frequency. You can't.
Well, frequency would be a lot easier.
You can't. There's no diffraction pattern in the pictures.
Yeah, because there's a harmonic resonance. If you
Sorry, not a resonance. Resonance would be something moving up and down in a frequency. Well, the light frequency is only described with a diffraction pattern, and there isn't one in this image. So no. Wrong.
Yeah, because it's it's not out of phase.
So not out of phase, not a wave.
So nobody's saying wave. I know.
Yeah, you are. That's what ether believers are saying. That's kind of like the globe anti-flat Earth rhetoric when they say nobody's claiming Earth curve. You Muppets claim light needs to traverse a medium called ether because it's a wave. It isn't. There's no picture you will present to me that has diffraction patterns in it to say that the light, in all instances, is capable of being described as a wave. It isn't, unless it's diffracting.
This is the whole purpose of discussing light in the ether. So we've discussed the many differentiations and definitions, but if we refer to the luminiferous ether, and I'll use the present tense instead of the past from Wiki. Luminiferous ether or ether is the postulated medium for the propagation of light. It is invoked to explain the ability or the apparent wave-based light to propagate through empty space, something that waves should not be able to do. That's the whole function of ether in a non-atomistic worldview, philosophy. That's its function because light behaves as a wave.
Thank you, Adam. So, Sin Cleanser, was that your crushing defeat, like the ballers when they say nobody's claiming the horizon is Earth curve, when you say nobody's claiming ether waves? Yeah, they are. There's just nothing in any photographs that I've got that have any light diffraction, so you can derive probability distribution to claim a wave in any instance, because light generally doesn't diffract.
Right. No, here's the thing. Hold on, Napalm, 1 second. Here's the thing. I don't know if these ether people are saying that they're arguing for waves. Yeah,
they are. Adam just read out a quote, you antagonistic little prick. So if you're just here to cause trouble and argue from the point of view that isn't the actual standpoint, then you're a prick. You're an antagonistic little prick then, Sin Cleanser. Sit down, shut up. If you don't know what they're claiming, then shut up.
Looking for attention again, Sin Cleanser?
Yeah, little attention seeker. Shouldn't you be off somewhere wanking?